Our sun is a star, a vast churning sphere of incandescent gas. For billions of years, it has bathed our planet in light and warmth, making life possible. This immense power comes from a single continuous process occurring deep within its core. This process is called nuclear fusion. It joins small things to make something new, releasing a tremendous amount of energy. To understand our future, we must first understand this stellar engine. Fusion creates energy because of a quirk of physics. When two hydrogen nuclei merge, they form a heavier nucleus through a series of steps into helium. The helium weighs slightly less than the hydrogen that made it. That missing mass becomes energy. As Einstein wrote, E equals mc squared. Energy born in the core wanders outward, then races to Earth as sunlight. The process of fusion is not simple. The hydrogen nuclei, protons, do not want to join together. Each proton is positively charged, like poles of magnets push away. This is the electrostatic or Coulomb force, an invisible barrier. To fuse, that repulsion must be overcome. At very short distances, the strong nuclear force takes over. It's the strongest force, but it acts over subatomic ranges. Close enough, it binds them into a new nucleus. On Sun and Earth, the first battle is the same, the Coulomb barrier. The Sun uses immense heat and quantum tunneling. Temperature is particle speed. At these temperatures, some collisions punch into the strong force zone. Most miss, a few hit hard enough to stick. Quantum tunneling lets a proton appear past the wall. Rare alone, decisive in vast numbers. As we heat matter, it changes state. Solid, liquid, gas add far more heat. We create a fourth state, plasma, a superheated, electrically charged gas. It's where fusion happens, stars and our experiments. A neutral atom has balanced charges, positive nucleus, negative electrons. Heat knocks electrons free, ions and free electrons. Because it's charged, plasma obeys electromagnetic fields. Introduce a magnetic field and particles spiral its lines. That property is key to control on Earth. Plasma fills the cosmos and our skies and streets. We can't use the sun's crushing gravity. No solid can touch 100 million degree plasma. Touch the wall, the fuel cools, fusion stops. The solution, hold plasma with magnetic fields. Never let it touch. The leading design is the tokamak, a Russian acronym, a donut-shaped vacuum chamber wrapped in powerful magnets. They create a closed magnetic path. Hot particles spiral and stay confined. The tokamak is also a transformer. Drive current through plasma, it heats resistively and adds a circular field that twists with the toroidal one, forming a stabilizing helical cage. Extra coils shape and position the plasma, keeping it clear of the walls. Recreating a star on Earth is an extreme challenge. Deuterium-tritium fusion needs over 150 million degrees, 10 times the sun's core. Creating and maintaining that heat demands vast power. Energy constantly tries to escape. Plasma is inherently unstable. Holding it is like catching jelly with a net of rubber bands. Small ripples can avalanche into disruptions, dumping the plasma into the wall and ending the shot. Machines must detect and suppress these events. The fuel and byproducts add more hurdles. Deuterium is abundant. Tritium is rare and radioactive, so we must breed it. A lithium blanket makes tritium as neutrons escape the plasma. Neutrons ignore magnets and hammer the walls. Over time, materials embrittle and become radioactive. We need alloys that endure for years, and we must beat the final test. Net energy gain Ignition. Sustained. Despite the difficulty, the work continues worldwide. The promise is extraordinary. Deuterium in the seas could power us for ages. Fusion is inherently safe. No chain reaction, no meltdown, no greenhouse gases and far more manageable waste, mostly helium. Structural radioactivity decays in decades, not millennia. Projects like ITER aim to prove sustained net gain. Big science advances the frontier, agile companies explore faster paths and fresh ideas. Together they accelerate discovery. The sun proves fusion works. Our task is to hold a small star. The road is long, but each experiment, each breakthrough brings us closer to clean, lasting energy for all. If you liked our content, hit the like button and subscribe to Science You Need to Know for more mind-bending science content.